Okay, here we have a question on isotopes, really. So it's about chlorine, and from a periodic table you see that the average atomic mass is 35.5 for chlorine, and you may know that chlorine has two isotopes. One is 35, right, and the other is 37. Right, so we've got two isotopes of chlorine that make up the chlorine gas. And if this is one mark really, so you have to be able to sort of do this intuitively in your head rather than with the long weighted average equation, right? So if they're the only two isotopes and the average of it has got to be 35.5, you can see that the ratio needs to be 1 to 3. All right, so for every 4 atoms, 3 of them need to be. Sorry, it's the other way around. It's 1, 2, 3. For every 3 atoms of chlorine 35, there is 1 atom of chlorine 37. Okay, so if you work out that average, it comes to 35.5. Right. So then we think about the chlorine molecule. Okay, so the chlorine molecule can be 2 atoms of chlorine 35. It can be 2 atoms of chlorine 37. Or it could be one of each. Okay, so you've got chlorine 35 and chlorine 35. So the MZ of that molecule is going to be 2 times 35 is 70. So we could have an alternative chlorine molecule, which is a 35 37, and that's going to be 72. And the third option that we have is we could have 2 37s, in which case that would be 74. So they are the three MZs that you'll get when you put chlorine in a mass spectrometer, and so that is part 1 done. If we now have a look at part 2, we need the relative intensities of the peaks. So relative intensities, of course, is another way of saying it's like the percent abundance, right? So in case you'd forgotten that, I'll just mention that. Okay, so all molecules are not going to be in equal proportions, right? So the MR70 molecule is not going to be in the same proportion to the MR72 or 74. Those molecules, they're going to be in different proportions. So that's what part 2 question is about. Is what the percent abundances of each of those molecules. So let's think. If we had 4 atoms, 3 of them would be chlorine 35 and 1 of them would be chlorine 37. But we wouldn't be able to make this molecule if we only had 4 atoms. So let's assume we've got 8 atoms. If we've got 8 atoms, then 6 of them are chlorine 35, and 2 of them would be chlorine 37. So now we have to do probabilities. Okay, so let's draw this chlorine 35 molecule out. What's the probability if we had these 8 atoms of making a chlorine 35 molecule? Well, that would be 0.75, right, times 0.75, because 3 out of 4 of them are chlorine 35s. Yeah, and so the probability would be 0.5625. All right, now if we look at the other molecule, so we've got a chlorine 35 and a chlorine 37, then that is actually the same, right? We could make that molecule by first coming up with a 35 and then secondly picking a 37, or we could alternatively get the same molecule by first picking a 37 and then picking a 35. So that is going to be 0.25 chance of getting a 37, all right, times 0.75 chance of getting a 35. but we can do that either way, right? So we're going to multiply that by 2, and that gives us a probability of 0.375. So that's that, and then the last option is 2 37s, in which case we've got a 0.25 chance of picking a 37, and we've got a 0.25 chance of picking a 37, and that comes out to 0.0625, I think. And then we just have to convert these into integers. So if we divided each one by 0.0625, we get 1 to 6 to 9, which would be the proportions of those 3 types of molecule in a sample of chlorine. And that answers part 2. Hope that's helped.